Hello friends. So today we are going to solve the questions from rotational motion and we are going to solve two questions. One question is from the year 2020 and another question is from the year 2022. And both these questions are from the advance. So the first question, it was asked in the year 2022 and it states that excuse me, please. At a time t is equal to 0, a disk of radius 1 meter starts to roll without slipping on a horizontal plane with an angular acceleration of alpha 2 by 3 radian per second square. A small stone is stuck to the disk. At t is equal to 0, it is at the contact point of the disk and the plane. Later, at time t is equal to square root of pi seconds, the stone detaches itself and flies off tangentially from the disk. The maximum height in meters reached by the stone measured from the plane is 1 by 2 plus x by 10. The value of x is. So this question is basically a combination of the rotational motion, which is without slipping, as well as the projectile motion, because the stone detaches itself and flies off tangentially. Okay, so it's a combination of both. So we can just draw an approximate figure for that. Suppose this is a plane and this is our disk, and it says that the stone is initially at this point of contact. Let us call this as point P. Okay. And it is rolling without slipping with the angular acceleration of alpha, which is given to us, and let us suppose r is its radius. When this disk moves by an angle of theta, and let us call this point as P prime, at this particular moment this stone detaches itself and with the angular velocity of, let us suppose that with some angular velocity, okay, some velocity, not angular velocity, and after that let us draw the plane of this for the projectile, and it is going to traverse a path which will be something like this, okay, and it is going to fall at the same level that of the plane, and we are supposed to find out what will be its maximum height, okay, maximum height from the plane, initial plane. Okay, so the plane will be here 2, one will be the initial plane on which this disk is rolling, and other plane will be above which the projectile motion we are going to consider. And let us call this as maximum height is suppose of h max, which is given to us in the form of an equation. Okay, and so let us write various things that are given to us. So first we are given the radius of the disk, let us suppose, and that is of r, which is equal to 1 meter, and we have an angular acceleration which is alpha. It is given as 2 by 3 radians per second square, and it states that disk starts from the rest. Okay, so initial velocity angular velocity rather, omega naught will be equal to 0. Initial angular velocity that is of omega naught is equal to 0. And the time taken for this point P to come to the point P prime, or we can say time taken by the stone from the point of contact to the point of detachment is given as T. Okay. So we can say that stone starts at point of contact. That point of contact is P, and detaches at P prime, and this time is given as square root of pi. We are also given this H max. We are given that our maximum height is our 1 by 2 plus x by 10, and based on this we are supposed to find out the value of x. So basically we are going to find out maximum height, equate with the given equation, and from there we are going to get our this maximum height. So first of all, we are interested in finding out this value of theta, that is the angular displacement. Okay, so for that we are going to use the basic equation for our rotational motion, and so we can say angular displacement at detachment, and that is basically P prime, and the equation we can use, that is our theta of t will be equal to our theta naught plus omega naught t plus half alpha t square, and this theta naught as well as omega naught is equal to 0. So this can be written as our half alpha t square. We already know value of our alpha as well as t, so this comes as half 2 by 3, and we have this as square root of pi and whole square. So from here we get our theta of t is equal to our this 2 cancel with 2, and this comes as pi by 3. Or simpler terms, let us say this theta is our pi by 3 radians. Now we are going to find out the height based on this rotation. Okay, so we are interested in finding out this height now, and let us call this height as y. So you can say height of point on the rolling disc, and this particular case it is also called as a cycloid motion. Cycloid motion. So no doubt the disk is rotating in a circular motion, but the height we are going to find out is a vertical motion, with is vertical height. So we can say that for a rolling disk, the vertical position of point P prime we have said let us this is our y, and that will be equal to r 1 minus cos of theta. Okay. And radius is over 1, theta we already found out, so this becomes 1 minus cos of pi by 3. So we get that our y is equal to over 1 by 2 meters. So basically what we did, so this is initial plane and the point starts with P and it rolls up till P prime. So we found out this vertical height of our P prime, that is our y, and after this P prime the stone will be as a projectile. So we can use the equation of projectile or formula for the projectile. Okay. And next we are going to solve, you can say, the vertical velocity at detachment, that is at a P prime. Okay. So we say vertical velocity at detachment. That is P prime. So we can use the instantaneous angular velocity formula, which gives us that omega is equal to omega naught plus alpha t. Omega naught is over 0. So this is equal to alpha t, which will be coming as 2 by 3 square root of pi. And then we can find out the, you can say, velocity also, because it will be launching, suppose, with a velocity of v. And in order to find out, we can use the same equation which we used previously, that y is equal to r1 minus cos of theta. It is also called as, sometimes called as, a parametric equation of a cycloid. So we can say that parametric equation of a cycloid, which will y is equal to r 1 minus cos of theta. And if we derivate it, we can find out the vertical velocity. So we can say the vertical velocity of a point on the rim. And let us suppose that is given as our v of y, and that will be equal to derivative of y with respect to time t, and that can be written as our, because the equation of y is in terms of theta, so we can just write it as our, if I derivate it, and we get this our r, this will be coming as d theta by dt, and we have this is sine of t. So we get that our v of y will be equal to our this r d theta by dt is our omega, and this is our sine of theta. Now we can just substitute the values. So we get that v of y is equal to r is our 1, angular velocity we found out is our 2/3 square root of pi, and we have this as sine of theta, which is pi by 3, and this will be coming as sine pi by 3 is square root of 3 by 2, so 2 and 2 cancels out, so we are left with square root of 3 pi divided by 3. So this is the vertical velocity at point P prime. Now we can easily find out our, you can say, maximum height after detachment. Maximum height after detachment. And for that we can use just conservation of energy, and at point P prime we are having half m, let me write, using conservation of energy, which gives us that a half m vy square is equal to mg, and let us call this height as delta h. Delta h, and here mass and mass cancels out, so we are interested in delta h because y we already know, so we can just add them later on to give us h max. So this gives us our delta h is equal to, we have here vy square upon 2g. We substitute value of vy square, and vy square will be equal to, let me, this is our square root of 3 pi divided by 3, and this comes as 2g, g is our 10, and this is a whole square. So we get this as 993 pi by pi square by 60 meters. Therefore, calculated h max is equal to our y plus delta h. Y we found out is our y2, delta h is our pi by 60, but this is given equal to as 1/2 plus pi by 6, sorry, not pi but x by 6, x by 6. Therefore we can say that the value of x will be equal to, one second, x by 10, yes. Here it is 60 and here it is x by 10. So this gives us pi by 6. Next question. It was asked in the year 2020 advance, and it states that a rod of mass m and length L pivoted at one of its end is hanging vertically, a bullet of same mass moving at a speed v strikes the rod horizontally at a distance x from its pivoted end and gets embedded in it. The combined system now rotates with the angular velocity omega, angular speed omega about the pivot. The maximum angular speed omega m is achieved for x is equal to xm. So we have to find out which of these equations are going to hold. The basic figure is given to us. We are having with velocity v, mass is same and it strikes at a distance of x from the pivot point. So pivot point is our p, and everything is measured with respect to this pivot point, the length as well as the distance of strike. And it says that the bullet gets embedded. Okay, so it means our okay. So here first of all we are going to use the conservation of angular momentum, and that for that we have to find out what will be our initial angular momentum. Initial angular momentum, and it says that the rod is at rest. Rod is at rest, therefore its angular momentum will be 0. Angular momentum will be 0. And it says that a bullet moves horizontally, and we assume that this pivot point is having a coordinate of 0, 0. Okay, so this is our origin, and so this will be our, in this case, our x-axis, and this is going to have our y-axis. Okay, so therefore the rod hangs in the negative y-axis, and this endpoint coordinate of this rod will be our 0, minus of L, and the point of impact of the bullet is at a distance of x, so this coordinate will be our 0, minus of x, and the direction of the velocity is in x direction. Okay, so we can say this as v of I, or we can also write it as v, 0 if we want, because we have considered x and y coordinate. So we can say that pivot point P, it is having a coordinate of origin, that is 0, 0, and you can also say from here that a rod hangs along negative y-axis, and from 0, 0 to 0, minus of L, and the bullet is traveling in positive our x-axis, bullet travels along positive x-axis. Therefore, we can write that the velocity v will be equal to v comma 0, and the bullet strikes at bullet strikes at 0 comma minus of x. Okay. Therefore, let us call this as a point P, and this point is a P prime, and this point, let us call this a S, where it strikes. So we can say that our position vector of our bullet relative to the pivot point position vector of the bullet relative to pivot and that is our r vector will be equal to our 0 comma minus of x, and the bullet is going to have a linear momentum. So you can say that the linear momentum of the bullet's linear momentum let us call this as p vector, which will equal to mass and velocity and with along with its coordinate, that is two coordinates x and y. Okay, no doubt it will be momentum will be only in x direction initially for the start. Now from here we can find out the angular momentum. Angular momentum of the bullet about pivot. About the pivot, let us call this as LB. B stands for bullet, will be equal to our R cross momentum, that is our P, and our R is our 0 minus x and 0 in 3-dimensional cross. We are going to have our MB comma 0 and comma 0, and we can say that our cross product LB will be equal to our 0 comma 0 minus MV x, and from here we can say that our magnitude of angular momentum is our mvx and directed along negative z axis, negative z axis. or basically we can, okay. Next we are going to find out the final angular momentum. Final angular momentum. Okay. And now the bullet will be embedded inside the rod. Okay, so we can call this a system, and system will be rod plus bullet, and they are going to rotate about the same angular speed, that is about omega. And therefore we can say it will be acting as system, and that system is our rod plus bullet, and the angular velocity is our omega. And in order to find out the angular momentum, we will be requiring our you can say moment of inertia also. Okay, so let me write the formula for our angular momentum. Let me put it here. Angular momentum, that is our final. So this is our L final will be equal to our moment of inertia of the system and angular velocity omega. So we are going to find out the angular momentum of the system, and this angular momentum of the system will be momentum of the rod plus momentum of the bullet. Sorry, not momentum, but moment of inertia of the rod plus moment of inertia of the bullet. So we can say that I of system will be equal to moment of inertia for the rod plus moment of inertia for the bullet, and our rod will be our half, sorry not half, but 1/3 ml square plus, and for bullet it will be our mx square. Therefore mass we can take as common, and we get this as moment of inertia for the system will be equal to m, and we have this as L square by 3 plus x square. Now we can easily find out our L final. So we can say angular momentum final, L final, is equal to our m L square by 3 plus x square multiplied by angular velocity, that is omega. Now we can use the conservation. Conservation of angular momentum, and this LB is our we can also call this L initial also, so let us call this Li. So we are having that our initial angular momentum will be equal to our final angular momentum, which gives us that our mvx will be equal to m L square by 3 plus x square and omega. Here m and m cancels out. From here we can calculate our omega. So we can say our omega will be equal to Vx, and this is left to us as L square by 3 plus x square. And we can just make minor adjustment in it. We can call this as a 3vx, and we have this as L square plus 3x square. So if we see that option number A is the correct one for our angular velocity. Okay. So you can say that option A is correct. A is correct. And A also, in the question also it's mentioned that at x equal to xm our angular velocity is maximum. Okay, so we can say that at x is equal to xm omega is maximum. So it means the angular velocity, we have to find out its the maximum value, or we can say maximize the angular speed. For that we are going to do its derivative and equate equal to 0. Okay, and that is going to help us to find out our maximum part. So we can say maximize angular speed we are going to do its first derivative and set equal to 0. Okay. So we already have our omega. So we have omega is equal to 3vx, and we have this as L square plus 3x square. And for the sake of simplicity, let us assume that our u is equal to our 3vx and our v is equal to L square plus 3x square. Later on we can just, therefore we can write that our omega will be equal to u upon v. So we get our d omega upon dt is equal to, we can use our v square, and this comes as our u prime v minus v prime u. Now we can just, let me write from here. So we can say our u prime will be our 3v and our v prime will be equal to our, this L square will be 0 and it will be coming as 6x. Therefore we can write that our omega will be equal to u prime is our 3v, so this comes as our 3v times our v is our L square plus 3x square minus v prime is our 6x, and this comes as 3v times x and divided by v square, that is L square plus 3x whole square, and this is the derivative d omega upon dt. And denominator, obviously when equated to 0, this is, we are not interested in denominator part, we are only interested in the numerator part, and the numerator will be giving us 3v L square minus 3x square, and we are going to equate equal to 0 to find out the critical point. Therefore 3v cannot be equal to 0, so from here we get that our L square minus 3x square will be equal to 0. This gives us that our x is equal to L upon square root of 3. Okay. So this is our, you can say, maximum value of x. xm. And one second. Okay, now we are going to substitute value of our, what we have to find out, I forgot one thing. Okay, we have to find out the maximum value. Okay, maximum value as well as omega m. Got it. So we found out that our xm is L upon square root of 3. So this L upon square root of 3 is, option number C is correct. Okay. Now based on this we are going to find out maximum value of omega. So from here we can say option C is correct. C is correct. Now the maximum value of omega, and it states that at x equal to xm, which is our L upon square root of 3, we get omega will be equal to omega m. So we simply substitute value of x and this will be giving us omega m. So we were having our omega is equal to 3vx upon L square plus 3x square. So let us calculate the denominator separately. So this comes as L square plus 3x square, which giving us our L square plus 3 multiplied by L upon square root of 3, and this is our whole square, and this will be coming as 2L square. Therefore we can write that of omega is equal to 3 times v L upon square root of 3, and it comes as 2L square. So this L square and L cancels out, and we can write this will be equal to our 3vl, and here, sorry, not L, 3v, and we have this as 2 square root of 3, and we can rationalize our, we can divide and multiply by square root of 3. So these two terms cancel with this 3, so this gives us square root of 3 times v divided by, I forgot to add L, 2L. Okay. And so this is our omega m is v square root of 3 to L. I think this we got the same one, v square root of 3 divided by 2, yes, and this is omega m. Okay, omega, and this is our omega m. Therefore we can say our omega m is equal to square root of 3 times v divided by 2L. So option D is correct. D is correct. So option D is correct. So here we got option A, C and D are the correct option for the this given question. So this we solved the 2 advanced questions from the year 2020 as well as 22. So these complete the 2 questions. Thank you.